All right, friends, welcome back. In this video, we're going to take a look at part 2 of your 7.2 day 2 videos. And in this video specifically, we're going to be taking a look at what you call matrix multiplication when you're trying to find what's called a dot product, okay? And so it turns out that that's a little bit of a tedious calculation, but I'm going to take you through all the steps of it, and we're going to do a couple of examples here in this video to show you exactly how you could find a dot product for yourself, okay? So before we start taking a look at the steps for performing a dot product, what we want to do first is give you guys a way that you can check to see if you even have the green light to do it in the first place, okay? It's going to turn out that depending on the matrices that you start with, you may or may not be able to perform a dot product. And so how can you tell if you've got the green light? Well, here to start us off, it says before multiplying two matrices that we might call A and B together, we first need to check for something. When we take a look at our two matrices A and B, we're going to need to take a look at their order, okay? Because it turns out that in order to perform a dot product, we're not going to be able to do that unless we have the number of columns of the first matrix exactly matching the number of rows in the second matrix, okay? So remember, that's how the order goes. It goes rows by columns. And so again, we're looking at the first matrix. That's the number of columns on the first matrix. It needs to exactly be equal to the number of rows in the other matrix, because that's the way that performing a dot product works. We're taking all the columns of A, and we're going to be multiplying it times all of the rows of B. And I'll show you how that looks here in a second. But that is definitely the most important thing to be checking for first before you start going through all the different processes of finding a dot product here, okay? If those don't match up, if the number here does not match the number here, then we do not have the green light to perform a dot product. So that's always something that you need to check for first. Another interesting thing is if they do match up, then one other thing that we can say here is that the order of the result of our dot product, A times B, is exactly going to be the other numbers in the order here, okay? So the order of AB is exactly going to be M by P, okay? And you can see that over here, right? And so we're going to see that as we go to some examples here today. But again, I cannot stress enough, you do not want to have to go through all the work of doing a dot product if you didn't have the green light in the first place. So we do need to make sure that the number of columns in the first matrix matches the number of rows in the second matrix. So that's the first thing I want to say here, okay? So let's say you have an example and that checks out for you, like say here in this example where I've got myself a matrix of order 2 by 3, and then I'm trying to find the dot product with that and a matrix with the order 3 by 2, okay? Well, I do have the green light to actually execute this because the number of columns in the first matrix is going to match the number of rows in the second matrix. And so because those match, I do have the green light here, and I know what the dimensions of the result are going to be. It's going to be a 2 by 2 that we're going to be ending up with here, okay? So that's just something to go ahead and point out first. So if you go ahead and read through the steps here, it says start with the first row of A and the first column of B, because remember, that's how a dot product works. We're going to take eventually all the rows of A and multiply it times all the columns of B, okay? And so the way that we do that, it says right here, is we're going to multiply matching members and then sum them up, okay? So we're going to multiply matching members, and then we're going to add up all the results of that. So the diagram over here, I feel like, does a really good job of kind of demonstrating what the process is here, right? So we are going to take the first row of the first matrix, so that is going to be that row 1, 2, 3, and we're going to multiply that row times the first column of the second matrix, which is what they have highlighted here, okay? How do you do that? Well, again, we're going to match up, we're going to multiply matching members here. And so here, what we mean by that is the first entry of this row is going to get multiplied times the first entry of this column here. So let's just kind of write out that off to the side over here. So we have 1 times 7. Okay. Next, we're going to go ahead and continue to match up members here. So let's go ahead and do the second entry of this row right here. We're going to multiply that times the second entry of that column. And so that's going to be 2 times 9. To follow up here, we have the very last entry of this row. We're going to multiply that times the very last entry of that column. And so that's going to be 3 times 11. Okay, and so that's what we mean there when I say multiply matching members. We're just going to go ahead and match up corresponding entries of that first row times corresponding entries of that first column, okay? And then what does it say to do? It says to sum them all up. So we're basically just going to go ahead and add up all the results of these, and that's going to be the result that we're going to have in the first entry of our matrix. So 1 times 7 is 7. We're going to have 2 times 9, which is 18. And then we're going to have 3 times 11, which is 33. So if you were to go ahead and add all these up, 7 plus 18 is going to give you 25. 25 plus 33 is going to give you 58. Okay? And 58 is exactly the number that you see over here in the diagram, which is what they wrote over here. Okay? Now, I acknowledge that is a very, very tedious calculation to have to do. So if you check the video that follows this one, I'm going to be showing you guys how to go ahead and punch some things into the TI-84 and make this a lot of an easier process for you to check. However, on the problems on the homework, I am going to ask that you guys show your work for this, which is going to be exactly what you see us doing here when we talk about how to perform a dot product here. So I know it's one of those tedious things, but luckily for us, it involves a lot of easy things to do, like multiplying and adding. So it's not going to be too bad. And plus, I'm not going to give you big matrices to do these with. So you could rest assured that while they are tedious, they're not going to be very challenging for you. Okay. Now that is, of course, is just our first entry in the resulting matrix that we're going to be ending up with. We of course have to figure out what is going to be going in all of these other entries here in the matrix before we're all finished up. And so the way that we continue here is we move on to step 2, where it's going to say we're going to do something very similar. We're now going to go ahead and take the first row of A. That's the same row that we started with in the last one. We're going to take the first row of A, and now we're going to multiply it times the second column of B. Because keep in mind, again, that's how this works. We're going to take all the rows of A, and we're going to multiply them times all the columns of B. Okay, so we get all the combinations here. So again, whenever we do this, we have the first entry times the first entry. So that is 1 times 8. We're going to have the second entry times the second entry, so that's going to be 2 times 10. And then we're going to have the third entry times the third entry, so that is going to be 3 times 12. Okay? We're going to figure out what all these are individually. So 1 times 8 is 8, 2 times 10 is 20, and 3 times 12 is 36. And then after we figure out all those individually, we just sum them all up. So 8 plus 20 is going to give you 28, and then 28 plus 36 is going to give you, wait for it, 64, okay? And so 64, you can see, is the entry that is in this column right here. So when you sum them all up, you do get 64, and so that is going to give us the next entry, okay? What we now follow up with is doing that exact same process, but all the different combinations that we missed, right? Again, we eventually need to take all of the rows of A and multiply it times all the columns of B. So you can see here in step 3, we're going to then continue with the second row of A times the first column of B. So let's just go ahead and take a look at what that would look like here, right? So even though the highlighting is different up top, we can still go ahead and perform this, right? So we're going to look at the second row of A. The first entry of that is a 4. We're going to multiply that times the first entry of the first column of B. So that'll be 7 here, right? So that'll be 4 times 7. So again, we're looking at here the second row of A and the first column of B. And so we just matched that up. That was 4 times 7. We'll now follow up here with a 5 times 9. Again, just matching up members here and multiplying them out. And then finally 6 times 11. That'll be 6 times 11 there, okay? And so 4 times 7, of course, is 28. 5 times 9 is going to give you 45. And then 6 times 11, of course, is going to give you 66. And then we sum them all up. So add all the way through. And we'll do a 28 plus 45 plus 66, and that is going to give you a 139 as the result, which is why you can see down here in the result, that is what we're going to have in that next entry, okay? And then finally, we're going to pick ourselves up here by doing the very last combination that we haven't done yet. That'll be the second row of A times the second column of B. So let's have a look at that here, right? So if we do the second row of A, that was this one, the 4, 5, 6, we're going to multiply that times the second column of B, which is the 8, 10, 12. And so that's going to be the first times the first, so 4 times 8 is going to be 32. We're then going to pick up with a 5 times 10, and that is going to give you 50. And then follow up with a 6 times 12. And 6 times 12, if I'm not mistaken, is going to give you 82. Okay, let me just check that before I move on here. Nope, I made a mistake there. That is actually 72. Okay, and then we're going to go ahead and add up all the results here, so sum these all up. And so that's going to give you 32 plus 50 plus 72, and that is going to give you 154. And that is exactly what you can see here is the entry given in that matrix right there. And so that is a very tedious process. I get it. We have to do a lot of adding and multiplying here. But again, while it is a lot, it is very tedious. It's a lot of easy stuff to do. Again, just be very careful, be very organized as you go through. All we're doing here is we're matching up all of the rows of the first one times all of the columns of the second one, and that's how we get our result, okay? And so what I want to do for the rest of the video is I basically just want to kind of take you through some examples of ones that are a little bit unique and just kind of stress and kind of reinforce that process as we go through here. So example 4, find the dot product of the given matrices. So first of all, we have to check to see if we have the green light, first of all. It looks like our first matrix here is a 1 by 3, 1 row, 3 columns. The second matrix here, this is a 3 row by 1 column matrix. And so again, if we're asking ourselves if we have the green light, remember that these inside numbers have to match up exactly, because we're going to have to take all the rows of A times all the columns of B here. And that does match up here for us really nicely. And we can see here that the remaining numbers here are 1 and 1, which tell us that the result of what we're going to get after we multiply is going to be a simple 1 by 1 matrix. And so that's pretty funny here, right? So let's go ahead and actually do that here. We only have 1 row of the first matrix to multiply times the 1 column of the second matrix here. So all we're going to do is we're going to match up corresponding members, multiply them up, and then sum them all together. So that's going to be the first entry of this first row times the first entry of that first column. So I'll show a little bit of work here. That's a 1 times 2. It's going to give you 2. Secondly, we have -2 times -1. That's going to give you +2. And then finally, we have a -3 times a +1. And that is going to give you -3, okay? And so once we go ahead and multiply all the matching members here, we have to go ahead and add these all up here. So if I go ahead and perform this, 2 plus 2 minus 3, essentially, that is simply going to give you 4 minus 3, or in other words, just simply 1, okay? So we end up with a matrix here that has 1 row and 1 column, and that is simply just going to be the matrix whose entry is solely 1, okay? So that's pretty nice. Let's go ahead and switch gears here to example B, where again, we have to check the order just so we make sure that we have the green light. This is a 3 by 1, and this is a 1 by 3. And so here we can see that matching up the inside numbers here, they are exactly the same. Pardon me. And we can see here that the remaining numbers turn out to be 3 and 3. So that means that the result after performing all of this is actually going to give us a 3 by 3 matrix, okay? So you can see how that's different, right? One of the things that you might be led to believe here, because you notice that we're using the same matrices, is that if we were to go ahead and take matrix A times matrix B, that is not going to be the same thing as matrix B times matrix A. And so that is going to be something the commutative property. That's something that we can do for real numbers, but it looks like here that's not something we're going to be able to do with matrices, okay? And so A times B is not the same thing as B times A, so that means that the order that you multiply your matrices in is very, very important, okay? So we'll just kind of keep that in mind as we go through here. Let's go ahead and actually perform this out, and remember, we want to take row of the first one times each column of the second one here. And so if we're actually going through and getting that done, the first row of my first matrix is just that one entry of 2. I need to go through and multiply that times each one of the columns of matrix B here. Okay, so I'm going to say that this is equal to, that's going to give you 2 times 1, and that is going to give you 2. Okay, now this would be the point where we would want to go ahead and sum up all of the entries here, but again, because we only have one entry in the first row of A and one entry in the first column of B, there really aren't multiple entries in these rows and columns for us to have to add up. So we can trust that the only entry in our result is going to be what we get when we just simply multiply those together. Okay, now for the next entry over, we have here the first item in the first row of A times the second item in the second column of B, and so that's going to give you 2 times -2, and that's going to give you -4 here, okay? So maybe what I'll do is I'll show a little bit of work just so you guys can later see where I'm getting my results from. So that was 2 by 2, or 2 by 1, and then we were doing 2 by 2, or I should say 2 by -2, okay? And then lastly, we're going to take the first entry of the first, and then multiply it times the third entry of the next one, so that's going to give you 2 times -3, and that is going to give you the first row of your result here. So we have more entries to figure out, but we can trust here in the final answer, we're going to have 2 times 1, which is 2, 2 times -2, which is -4, and then 2 times -3, which is -6. That's going to give us the first row of our final result, okay? We're now going to go through and do that exact same thing for the next row down in our first matrix, and that looks like is solely the entry -1. We're going to multiply -1 times all of the entries here in the second matrix here. So that'll be -1 times 1, -1 times -2, and -1 times -3, okay? Multiplying all those out, that's going to give you -1, +2, and +3 as the next row of your result. And then finally, we're going to go ahead and pick up with the last entry of that last row in the first matrix. That's going to be 1, and we're going to simply multiply that times all the entries there in that second matrix. So that's going to be 1 times 1, 1 times -2, and 1 times -3, okay? So that'll be 1, -2, and -3, and that gives us our final result there, okay? And so, again, a very, very tedious thing to have to do. Make sure that you pay attention to today's Schoology folder, where I'm going to go ahead and leave a link to a video that I made that describes how to go ahead and check these answers in the TI-84 calculator, okay? Keep in mind, I would still like you to be showing your work if this was a test or quiz situation, so knowing how the multiplication works out is something that you will need to be responsible for. So showing work that looks exactly like this on a quiz or test is going to be something that's required for you down the line. So you can't just skate by knowing how to use it in the calculator. We got to know how to do it by hand, okay? But that's a couple of examples there. What I want to do is go ahead and move on to this next example here, which is example 5. It says, given the matrices A and B, what we want to do is perform each of the following dot products. And you can see that I've already done B times A. I'll take you through really quickly how we would do A times B. And just to check real quick, again, we have to check the order of these matrices. This is a 2 by 3, and this right here is a 3 by 2. And of course, those inside dimensions are going to be matching up here for us. And so that, of course, gives us the green light to perform this, this dot product. And we know that the result of that is simply just going to give us a 2 by 2 when we're all said and done here. So let's go ahead and actually multiply these together in that order of A first times B second. And so keep in mind here, whenever you multiply matrices, order does matter. So I'm just going to write this out. 1, 2, 0, -1, 3, -2. That is matrix A. And we're going to multiply that times matrix B, which you can see over there is -2, 1, -1, 4, 0, 1. And this is the problem that we set up here for ourselves. Okay, so just going through here yet again, we're just going to go ahead and start ourselves off here with doing the first row of the A times the first column of B, okay? We're just going to match up corresponding members, multiply them out, and then we're going to go ahead and add up the results here. So let's just go ahead and work that out here, right? That's going to give you 1 times -2. And then we're going to add on 0 times 1, and then add on 3 times -1. Okay, so the first terms, the second terms, the third terms have all been matched up and multiplied, and we're just adding up all the results there. We'll figure out what that is here a little bit later. What we now want to do is go ahead and take the first row of the first matrix times the second column of the second matrix, okay? And so we can go ahead and do that right here. We could go ahead and say that that is going to be matching up the first terms, 1 and 4, add on matching up the second terms, 0 and 0, and then add on matching up the third terms there, that's going to be 3 and 1, okay? And so, again, when we say show the work, this is what we mean to say, is make sure that you go through and you know how to go ahead and match up corresponding members and multiply them out and then sum up of the results here. We're going to pick up here with the second row, so that's going to be your second row of the first matrix. We're going to multiply times the first column of the first matrix. So again, all the different combinations here, right? We're going to have matching up the first term, so that's going to be 2 times -2, plus the second term, so that's -1 times 1, plus the third terms there, that's going to give you -2 times -1, okay? And then finally, let's just go ahead and do the last combination there. We have the second row of the first times the second column of the next, okay? So that's going to be 2 times 4, which is the first terms. That's going to be plus -1 times 0 for the second terms here. And hopefully OneNote does not crash on me here. It looks like it's about to. So we'll go ahead and get that restarted here in just a moment. It looks like, there it goes. Technical difficulties, one moment. We'll get that reopened. Okay, there we go. So we are back here, and we're going to go ahead and continue on here. Again, we're multiplying the first row, or sorry, not the first row, the second row of the first matrix times the second column of the second matrix, and just kind of matching up terms here. So yet again, that was 2 times 4 plus -1 times 0 plus -2 times 1, okay? And so now that you've set all this up, you can now just go ahead and use some mental math to go ahead and figure all this out, right? So in that first entry here, I'm looking at this guy. That is going to give you 1 times -2, that's -2, plus 0 times 1, that's just 0, plus 3 times -1, that's -3. So we have -2 plus -3, that's going to give you -5, okay? Pick up here with this next entry here, we have 1 times 4, which is 4, plus 0 times 0, which is 0, plus 3 times 1, which is 3, so that'll be a 4 plus 3. That'll give you 7. This next entry, which is right here, we're going to go ahead and do 2 times -2, which is -4, plus -1 times 1, which is -1, plus -2 times -1, which is +2. So that gives you -4 plus -1. That gives you -5, and then we're going to add on a +3. So that'll actually give you -2. And then finally, we can go ahead and perform here this last one here. So that is going to give you 2 times 4, which is 8, plus -1 times 0, which is just 0, and then plus -2 times 1, which is -2. So that'll be 8 plus -2, and that is going to give you 6. Okay? So there is your final result of what we've got going on here. Okay? Now, very, very tedious to do by hand. I understand here. Here is a quick snapshot of part B, where you can see here that I basically just went ahead and reversed that process. And yet again, this is another example of why, if you were to go ahead and multiply these matrices in the order of A times B, it is not going to be equal to reversing that order B times A. We're going to get an entirely different matrix, and so we do not have a commutative property whenever we multiply matrices like this, okay? So I'll invite you to pause the screen and take a look at part B there, and I'll also invite you here to go ahead and pause the screen and take a look at example 6, where we're doing much the same thing, except now I just have some simple 2x2 matrices here, and you can see that we do have the green light to go through and perform these multiplications here because those inside dimensions do match up here for us. Now, again, if you're stressing, if you're looking at this and you're saying this does not make sense at all, first of all, I would encourage you to go back and maybe rewind the video and watch it again. I know that this is a long process, but it is a process that involves a lot of easy calculations as you go through. It's just a matter of knowing how to organize your work and how to proceed here. So I encourage you to rewatch the video, A. B, again, make sure to catch the other Schoology video here in the folder today. It's going to tell you how you can actually perform matrix operations using the TI-84. So this can be a very handy way that you go through and check your results of what you're doing here. So that's going to do it for this video. Thank you very much for your attention. If you guys have any questions whatsoever, please feel free to reach out. Matrix multiplication, very tedious thing, but also a very easy thing. So thank you very much for your attention, and I'll speak to you in the next one.